Okay, uh, in this session, I want to show you some tools that you can use for doing linear regression using Python. So Python has access to a whole bunch of packages, and these are libraries that have predefined classes, and classes have methods, and all those work done by people who are not necessarily the ones who created Python are available to any users. And the Anaconda implementation we use already have many of these libraries already included, so we should be good to go. And we'll start with using Pandas for reading the data file. And Pandas has data frame as one of the major class. And so data from objects have access to methods that are specific to statistical analysis, such as descriptive statistics, including max, mean, median, skewness, etc. You can also do correlations between variables, and you can also do histograms. So we'll see how to use pandas for doing those kind of things. And then the linear regression can be done using the SciPy package and the stats module of SciPy package. And it is something that the textbook talks about, and also it's something that's pretty easy to use, but the limitation is that this linear regression model method is good only for simple linear regression, meaning like one independent variable and one dependent variable. It's a good way to get introduction into linear regression. And the linear regression, of course, whenever you do with two variables, of course, it's good to kind of see the result or as a chart. So the Seaborn's package regplot method has ways to visualize this linear regression. And finally, if you have multiple regression that you want to run, again, there are many options, and we're going to look at the sklearn's linear model package and for multiple regression. And so the rest of the demo, I'll show you how to read a CSV file and take a look at the data and also the columns. And we'll also use some basic data frame methods like describe, mean, median, etc. to get to know the data. And then we'll also look at the data frames correlation method, and allows you to create a correlation matrix using heat. We'll display it using Seaborn's heat map method, and then we look at the linear regression method of SciPy packages stats module, and we'll create a simple linear regression, and then we'll also use that regression to predict some values. And then we'll go into multiple linear regression using the sklearn module, and then we'll use for prediction. For now, we'll simply use Python to build the expressions for predictions. Okay, and the data file itself, it's simply some data file that has information about counties and people who voted for having casino there or some kind of gambling or against casinos, and total number of people who cast their vote, and then population of the county, and some variable called PCI, median household income, and size of, I guess, the county and population, etc. So you got some numeric data. These are sort of a macroeconomic type of data, and each observation is for each county. Okay, and so to begin with, we'll look at just three variables: population, median, family income, and poverty level. And we'll try and predict poverty level as a dependent variable. So poverty level versus population, poverty level versus median, family income is what we'll use. And first we'll start with doing some descriptive statistics and histograms and also correlations and a heat map for correlations. Then we'll go into linear regression, simple linear regression, where poverty level is defined as a function of median, family income. And then you'll also see multiple linear regression and how poverty level is defined as a function of median family income and population, and we'll see how to do predictions. All right, so just hang on and we'll get started. Okay, so here I am running Jupyter Notebook. So let me go ahead and create a new file, and new 3. So let me just call this regression demo. Okay, so first thing is we need to import the file, and the file I'm looking for, it's this one. So it's a CSV file. We got data on county, for, against, total cast, total number of votes cast, ballot type, population, and so on. So this is the CSV file I want to import, and let me go ahead and okay, there we go. So switch to here. All right, so we'll start by first thing I need to know where my folder is. Okay, and so right now in Jupyter, to find out, of course, sometimes the hint is in the path name of the Jupyter notebook we are loading. Right now it's under documents teaching CI650, and so that %20 is the space between CIS and 650. Now, of course, if you aren't sure, you can also use the operating system's OS model, OS, to find out where my current folder is. And so os.getCwd will tell me that I'm currently in C users nice G document / teaching / CS 650. If I want to know what files are here, I can do os dot, I think it's dir list. No, maybe it's list dir. Yeah, so list dir list all the files in this folder and just the file names, and you can also look up documentation on OS. So this gives you, this OS package gives you access to operating system commands that are from within. It works the same way whether you're doing it through Jupyter Notebook or through Interactive Python, so, or the Python terminal. All right, so that's good, and so let's go ahead, and I know where my file is, and so next thing I need to know is the file I'm looking for is it's called data for regression.cs with this one. Okay, so let's go ahead and import Pandas as PD and run that, and it's went through. Let's look at this. Okay, and the next step is I need to read my file, so I'll call it just data. Let's call it county data equals pd.read CSV, and the file name is data file for regression. Okay, let's make sure of that. Okay. So data for regression.csv. Data for regression. So that went through. Once you got the data, it'll be a good idea to take a look at it, and county data dot head will show us top few rows, and also I could do county data dot tail to see the bottom few rows. Looks good. And so what else can we do? We can also look at how large the file is, how large the size, number of columns there are. So I can do county data dot columns. Gives me the list of all the column names. Okay, and also I can look at the size of this data frame. So county data dot size tells me there are 1050, but there are only 50 rows. But how come we got 1050? Because the number of columns is 21. So 21 times 50 is 1050. If you want to know the number of rows and columns, you use the shape property. County data dot shape is 50 by 21. All right, and we can also look at the column names. Right now, every row in here corresponds to a county number. So county number is an attribute also, but we'll make that as an index. We're not going to do any county number specific thing, but it's a good idea to mark what column will be the sort of an identifier for each row. So to do that, I will do county. The command is county data dot set index. Set is lowercase set underscore index, and it uses a list as input, and inside the list I simply specify the column names. The column name should be exactly spelled out, including its case sensitive county. So this way I can specify that as the index. Doesn't like that. County data set. None of the columns. Oh, it's N capital. Okay. All right, that went through. So there it is. Okay, so we got the data, all 50 rows, and next thing what you want to do is we can start using the methods. And so one is the describe method is pretty handy. So if I do county data describe, it shows me the descriptive statistics for every variable, and by default it shows count, mean, standard deviation, minimum, first quartile, median, third quartile, and maximum. It doesn't show other things like skewness and so on. We can count it, we can calculate it separately. And so if I do let me do if I county data dot skew, let me see if that works. Okay, there it is. So these are the skew numbers for county data, and whenever you see a skew that is close to 0, that means there is no skew. It's kind of a symmetric distribution. And so obviously county number is like a 1, 2, 3 numbers. Ballot types, they're all the same, so there's no skew there. But some numbers are like population density is highly skewed, right skewed. See this 6 point. So any number above 0 is right skew or a positive skew. So this is a right skew. This is the right skew. So percent of black population is right skew, and percent of other is right skew, and percent female is left skew. Okay, so there are a few counties very with low female percent population, and so on. So this is, I can use this to look at the skew. You can also use this to look at the median. So that's the median of these numbers. And for every variable I can find out. I can also specify a specific column and look for its basic summary statistics numbers. So all I have to do is I have to specify the data set dot, and the second part, after the dot, let's say if I want to know the population mean, I could do population. That becomes an attribute of county data, and then I can do dot mean, and that gives me the population mean. I can also do the median like that. County data dot population dot median. There it is. So that works there too. All right. So this way we can look at descriptive statistics of any column, any variable. All right. Next thing is we're going to take a look at the histogram. Now, histogram is also it's a method available within Pandas data frame, and so to create histogram, we will use the matplotlib. Okay, so to do matplotlib, I have to do I think pound symbol matplotlib. Wait a minute. Okay, that's I need to include it. So to access the matplotlib, I got to say %matplotlib here, and then I can then add a histogram to it. So I create a histogram. Let's call it. So let's say we want to do a histogram of population. So to do that, let me just call it population histogram equals, and that's simply going with the data frame. So county data dot population dot hist. Enter. Okay, so it's done now. What I get is I get the it opens. It's a result of the population histogram. Now, of course, I can take a look at this. I can study the property, and change the title of this. Can give this a title. Population, apply. There it is. And x-axis goes from, so these are numbers, they go up to 400,000. So if you want, you can make it go from, this is a small sort of observation, so we could play with this x-axis, the minimum maximum values, and work on it, but I'll let you figure that out. Click OK. So we got histogram already done, and next thing what we want to do is we want to try and create look at the variables and correlations and all that. So that's the next thing. So now, of course, when you do want to do correlation, remember we want to look at poverty level as a function of median family income. Okay, and so go back here, and we want to create a correlation. Well, correlation matrix is very important to use to study all the variables, how they are related and all that. And so we'll start by the correlation is also happens to be a method just like histogram, a method of data frames. So let me call it correlations equals I'll do county data dot core. I believe that should do it, and this computes correlation for every pair of numeric variable, and I run this. Okay, it went through, and once I got this, I can print it. So I can do correlations. There it is. So here's the result, and it's a square matrix, right? It's 21 rows, 21 columns, and the diagonal element is always 1.0. That's because that's one variable against itself, so obviously expect that to be 1.0. And this is good to have this, but it's simply shown as a I believe it's shown as a data frame itself. And now, of course, you can use data frame specific commands to study this correlation matrix. Let's check it out. So I just want to see type of correlations is it's a data frame. So all the data frame specific methods for accessing specific row or column of this can be applied to these correlations data frame. But what I want to show is I want to use I want to show it as a heat map, and so a heat map is something that we will use using Seaborn. Okay, and so I need to use import Seaborn as SN. So it's kind of working now, and once it's ready, it's kind of busy. Once it's ready, it'll turn white, and then there it is. Then we can go ahead and show the heat map, and we got the correlations already created. So next step is to use Seaborn's heat map. So it's to do that you do SNS, or SN is the Seaborn, and a dot heat map, and it needs a data frame as input, and the data frame we have is correlations. And the colors by default has I don't like the colors, so we can use a different color map. C map we'll use it red and blue, so RDBU. Okay, so this will show from dark red to dark blue, and enter. So there it is. So here's the result of the data of the correlation matrix. And so obviously by looking at this, anything that's kind of pale means they are not of interest, but anything that's dark blue, closer to dark blue or closer to dark red, are of interest. This is really dark blue, so percent this particular. Okay. Okay. All right. So we can see that we got the variables we're interested in is income, median family income. So that has a negative correlation with poverty level. So that's a strong negative correlation. That's red color here. And then we got number of churches, number of members, population, poverty level, and income. It's right there too. Same thing. And we can also look at the other variable we were interested in was median family income and population. Okay, so population is highly correlated with median family income or not. I'm not sure. So here's population here along this column. Median family income is right there. So it's not a strong correlation. It's kind of weak positive correlation. But we have decided to use it. But you could probably use something else like PCI. Probably has a stronger correlation with poverty. But basic idea is you want to use this to study relationship, or the strength of relationship among the variables when you consider two variables at a time. And this one, of course, you can save this as I believe you can save it as a PDF or a PNG file. And so yeah, it is saved as a PNG file. Okay, great. All right, now that we have figured out what variables to look for in regression, the next step is to actually do the regression. For simple linear regression, we will use the SciPy stats package, and then it's got a method called linear regress, and we'll use that. So so I've got to first do import from SciPy. That's scientific Python import stats. Okay, so I do that, and then once I have access to those, there's one of them is called stat linear regress. Okay, and and I'm going to call this regression 1. regression 1 is going to be between, so it's coming from stats, and the name of the method is linear regress. So that'll create a regression object, and this uses two arguments. The first argument is what the x variable is, and second argument is what the y variable is. So we want to use we want to use family income as a way to describe poverty level. Okay, so to do that, x equals, now family income is median family income. That happens to be a column in my data set. So I'll access the county data set, then I'll specify the column name. Now the column name is median underscore family underscore income, comma, and the dependent variable is the unemployment rate. Okay, unemployment rate or poverty. Okay, let's do unemployment rate. Let's see, county data dot, we got unemployment. Let's do poverty level. Okay, poverty underscore level. All right, let's do that, and I think this is it. So let's check it out. And this, okay, got a problem. Positional argument follows keyword argument. Okay, so I got to specify x equals, then it's the y equals. Okay, that went through. So that's the name of the first argument, and that's a value for the first argument. Name the second argument, value for the second argument. Now I can take a look at what regression 1 has, and so if I simply do regression 1, it gives me the output. Okay, so you got the slope, the intercept, the R value, p value. P value is it's really small. It's positive. I mean, very small. That means a good regression, and the standard error. So we got these, and once you got this, we can also so we got these individual numbers, and we can actually look at them by specifying the variable, the attribute of regression. So if I do regression 1 dot slope, it tells me that's a number. Okay, and if I want a regression number intercept, so I'll do regression 1 dot intercept. All right, so that's good. So we got access to the specific outputs within the regression, and we can use this for predictions. So let's say if we got income of the income numbers are, so these are the median income numbers. So if I do median, it's 27,550, and we want to know how that affects poverty level. The poverty level numbers are around it's 14%, 14.25. So if I want to predict poverty for, let's say, a 30,000 income, how will I do that? So I'll just do predict poverty level for median income of 30,000. Okay, so let's say prediction 1 equals, so it's going to be the intercept plus slope times the x value. So the intercept will be regression 1 dot intercept plus x is 30,000, so 30,000 times the slope. So slope is regression 1 dot slope, and then I can see what the result is. It's 14.885. So this way I can calculate for most values of income, as long as it is within the range of the lowest and highest. I should be able to come up with fairly decent prediction. Now, one other thing we can do is to actually plot this regression. And to plot a regression, we don't have to use this regression as an input. Instead, we'll use the Seaborn's regplot method. So if I do, let's create, okay. All right. So the way it works is we already have imported Seaborn earlier. So it's called SN. Yeah, there it is. We're already importing Seaborn. And then what we'll do is we'll use some white background for the linear regression scatter plot, and so that will be, I'll do sn dot set style, and then wet grade is what I'll use as the background, and enter. It went through. And next what I do is I need to tell what the axis of this will be. So axis equals, okay, I'll have to say, I'll make SN's regplot method. The regplot method uses two columns. The first column is the y variable, okay, and so I'm sorry, we need to specify two values, x and y, okay. Regplot. So x is going to be the same as what I had used before. So the same thing, I can just copy this from here and paste it here. Okay, so that's good. Enter. And here's the result of the poverty level as defined by family income. And so as you can see, there is an overall negative relationship. So it's kind of as lower values, meaning, of course, poverty level is high. Higher income means poverty level is low. That's what you would expect. And there is a straight line regression model for this describing the relationship between these two variables. And also there's the shaded line here refers to the confidence interval. So 95% confidence interval. It's the narrowest. Like if I picked a number 30,000, that's very close to, will be close to the actual, poverty level. So confidence interval is really narrow. As you go further away from the midpoint, the confidence level expands. So in other words, you may be, it'll be more of like a wider range in terms of what your actual number may be. So in other words, this is if you have a simple linear regression, you can use the regplot method of Seaborn package and specify two columns, one for x, one for y, and it automatically does all that. And you can also play with it to see change some of its layouts and so on. So that's good. All right. Next we're going to do multiple linear regression. So to do multiple linear regression, we'll use sklearn linear model. So from sklearn dot linear model, linear underscore model dot. From here I want to import a thing called linear regression. So that's doing it now. So sklearn is the data mining capable package that allows you to take a data set and create models, and then compare models and all that in one, all within sklearn. But we are simply going to use it only for running simple linear regression. So this one I'll call it regression 2, and for this one I'll use linear regression. First thing I need to do is I need to initialize it. So linear regression happens to be a class within sklearn linear model, and so I have that. So it's initialized. Next thing is I need to specify, I need to kind of create an array for my independent variables. Okay, so independent variables 1. Okay, so this one, independent variables, this needs to be actually a list of actual columns of data from the original data set. So I need to use the dot log method of the data frame, county data dot log, and I need to specify, whenever you're using location, you have to specify two parts, like the row and column, or rows and columns. I want all the rows, and so I want to go from 0 to the end of the rows. So I'll simply, instead of 0 to something, I'll just use that's for all the rows. And what specific columns I want population, and this one, since it's going to be a collection of columns, I want to extract from county data, and so I want to have so these two, medium, family, income, and population, is what I want to extract as independent variables. And so all the rows, and then from here I want specific columns. The columns will be, first will be population, and the second column will be, second column is medium, family, income. Alright, so this has to be shown inside an array, because I have an array is basically a list of columns is what I want. And I run this. It went through, no syntax error. I can take a look at what values I got here. So independent variables 1. Okay, there you go. So these are the numbers. Very good. And next thing what I want to do is I can go ahead and now this one, this is actually I believe it's a data frame. So I can take a look at this. So we can do type independent variables 1. That is a data frame, so that's good. And next thing is I'm going to go ahead and fit the linear regression. So I have created the linear regression object already called regression 2, and now what I do is I simply fit it. So I'll do regression 2 dot fit, and when I say fit, I had to specify what my x and y variables are. Now earlier we said we did x and y, earlier here. So when we did x and y, we used lowercase x for the independent variable and lowercase y for the dependent variable. So in math, whenever we're using just one variable, we use lowercase, but we have a collection of variables, we use uppercase. So in this case, since we have a multiple linear regression, x is going to be uppercase, okay, because there are more than one variables we are looking at, and they are nothing but our independent variables. Independent variables 1. Okay, that is the first one, and then I have to specify what my dependent variable is. So that's going to be the poverty level, right? So that's lowercase y equals county data dot poverty level, and I think that's it. Let's go ahead and run this. It ran and came up with an output, and if I want to see what the output looks like, let me see regression 2. Okay, that's output, and if I want to see the result of it, let me see if there's a way to print it. Okay, looks like I have to individually access its attributes. So just like before, the regression 2 has coefficients and intercepts. So I can type coef. So to access coef, I had to do coef underscore. So coef is an array of values. Okay, so the two values, since we have two independent variables, we got The first one is population, the second one is median family income. So you got two coefficients for that. So this is for population, that's for median family income. That's good. And we can also look at the intercept. So we do regression to dot intercept underscore, I think. There it is. Okay, that's intercept underscore. So in case both the independent variables were 0, this will be the resulting poverty level. All right, and okay, now we got this. We can also we can take a look at we can do some prediction. Okay, so let's say you want to predict let's say predict poverty level for we got two columns, right? We got the first column is population, second column is median income. So for population, I'm going to pick a number that's close to the midpoint of median of population, and so we got okay, we got the shape. Here's medians. Okay, good. And population median is about 10,000. Okay, 10,815, and median family income is 27,000. So I'll pick 10,000 and 30,000 or 25,000 for median family income, and then try to find out what poverty level will be. Okay, so let's see, population equals 10,000 and median family income of 25,000. Okay, and so we'll see prediction 2. Okay, I'm going to basically take these two numbers. First, I need to add the intercept first. So I'll do regression to dot intercept plus, and we got 10,000 is the median family, is the population. So 10,000 times, and I want to access the first coefficient of a regression coefficient. Okay, so to do that, I'll have to do regression to dot coef underscore. First one will be 0. Okay, that's the first coefficient, plus 25,000 is the income, so 25,000 times the second coefficient is that number, negative 6.5. So that will be don't use the actual number, instead use the variable name. Okay, when you're doing this regression to dot coef underscore, and now the one we want is the first one, I mean index 1, so that's the second one actually. Enter, and it took it. Can then take a look at what the prediction number is. It's prediction 2. There it is. So according to the linear regression model, the intercept, the predicted poverty level is pretty high, 18,000. All right, so this way I showed you how you can use different packages for doing linear regression, and how to compute, how to make predictions, and also how to create visualizations. And hope you find this useful. Thanks, and if you have any comments, I'll be glad to review them. Thanks.